Thank you. Yeah, welcome to this Gradle meetup. I'm super excited about the Gradle Lint talk. It's amazing stuff, but I don't want to spoil what John has to show. But it's part of the story. Elegant builds at scale. How do you maintain the health of your build infrastructure, the health of the craziness your developers might do with the build scripts, right? And that's where the Gradle Lint plugin comes in. So talking about scale, so Gradle has an enormous momentum, right? We had 10.4 million downloads in 2015. That doesn't include all the Android Studio, Android downloads that is bundled with. It's probably the most popular if you count across platforms, right? Java, Android, CC++, probably the most popular build system in the world by now. And but there's still so much pain in our domain, right? The problem we have is that the colors are somehow screwed when it comes from by the connection to the projector. So what is red is green, and anyhow. But so this guy has even more pain with these colors, right? A green face. So this is kind of the state of the average enterprise build master, right? There's hardly a company where everyone is saying, hey, our build is amazing, everything is perfect, developers are so productive. That is a rare thing, right? There might be a handful of companies in the world on a larger scale that can say that, and even they are still pioneering. Pardon? Oh, yeah. And there are many reasons for that situation. The scalability is a big part of the problem, and the situation is getting worse, right? It's not like there's still some eyesight left and still some breathing, right? But not for long, right? When you're in that situation, right? Code bases are growing, software is eating the world. The movement to a microservice architecture, right, in many organizations is an enormous challenge for the continuous delivery architecture, going from one or few releasable units to many independently releasable units. The heterogeneity of the technology stack is increasing and increasing. So there are more and more challenges. So investing into the build platform is a question of survival to continue to be productive, right? That's the situation we are in. So for us, it's the golden age for next generation build platforms. And one big problem of that is dependency management. You're smiling and just.
I've seen a graph like that before.
Okay. Yes. Well, it's so and the funny thing is, I mean, we talked about AND, right? And I also still remember when AND came out. But it's interesting that the pain we are talking about has been around for a long time. It's always fascinating why it hasn't been solved earlier. There are so many obvious problems, right, in our domain, and you would think, hey, it's 2016, right? Certain things are so obvious. Why is there no easy solution for that? So I will just go through some of those and show how we solve that. And so one thing is in dependency management, right? Typical problem is a substitution problem. So a dependency, let's say Guava is replacing Google Collection, right? Or a company got acquired and you need to change basically the name, but it's the same artifact in a new version that replaces an older one with the same name. When you do dependency management with Maven or with Ivy, how do you solve such a problem? Any ideas? Lots of excludes, which is a fragile solution, right? But it's a shitty solution and it's a fragile solution, right? So let's look at a simple example. Can you see in the last row? I wouldn't know what to do if you say no, but but I'm glad to hear that you can. So okay, so I just have here two arbitrary libraries, JSON token and WireMock. Not very famous, but that doesn't matter in this context. And I now ask Gradle, hey, show me the dependencies, right, including the transitive graph for my compile dependencies. And what you can see is you have the JSON token dependencies, and JSON token has a dependency on Google Collections, right? And then you have WireMock, and WireMock has a dependency on Guava, right? So many have exactly that specific problem, right? So what you can now do with Gradle, you can simply say, hey, Google Collections is replaced by Guava. And then after you say that, oops, why is this not stopping? After you say that, you see now in the Gradle dependencies report, it tells, okay, Google, I no longer use Google Collections for the JSON token dependency. I use Google Guava. Right? So with a simple statement, right, you can express that fact as a dependency is replaced by another one, and then we replace it in the whole transitive graph. So when you now do the following, right, when you remove the WireMock dependency, right, then you do the dependency report again, and now you can see JSON token has again a dependency on Google Collections. That's something that wouldn't work with excludes, right? So you always have to keep that in mind. Oh, now when you remove the first level, you depend now on the transitive graph of another dependency that your other dependency is working. That is a big part of the scalability problem, dealing with your large Java library class path, right? And you need to have straightforward and sane solutions to do so. And that is a simple problem where with other build system there is no reasonable solution. Of course, what is important to understand in those demos, right? What you can see is that is now in the actual build script code. Usually those rules would live in an enterprise plugin that is automatically consumed by all your Gradle builds, so a developer wouldn't need to specify that. In the perfect world, that information would be in the metadata, let's say in the XML metadata in Maven Central, right? We would have richer metadata descriptions, and the people that produce Guava can say, hey, we replace Google Collections. Or Google Collections can modify the metadata and say, we are replaced by Guava. Right? Then you wouldn't need to specify it, yourself, but for the time being, it's much better that you can specify it, considering that the metadata in the Java repositories is not rich enough to tell you that this is the case. Right? So that's one example. The other thing is working with dynamic dependencies. Right? That is that has a lot of challenges for organizations, right? And who of you is using something like Maven snapshots or some form of dynamic dependencies? So what we do in this example, we say, hey, we have a dependency on the latest version of Hibernate Validator, right? So, and if we now look at the dependency report and look at the graph, you can see, okay, the latest version of Hibernate Validator in the repository that we are connecting to is 5.2.0 beta 1. Okay. What you can do now with Gradle, you can now filter which of the latest versions you want to have. So you can provide us with a resolution strategy and say, for the dependencies of type Hibernate Validator, right, I want to define a selection criteria, and every dependency that contains the term alpha or beta should be rejected, right? So, and after you specify such a rule, you see what is now picked is 5.1.3 final, right? That is the latest one that fulfills the selection criteria. So you can run in info mode, and then the console output will tell you exactly that those two dependencies, beta 1 and alpha 1, were candidates but were rejected because of this rule. Right? So you can specify those rules not just for particular dependencies. You can say that is the rule for all the dependencies, or for all the dependencies that belong to my company, right? And then the output will be the same 5.1.3 final in this case. So you can also say, you can also blacklist dependency with that mechanism. You can say, hey, a 513 final is known as a bad version. It has a bug that doesn't work in our corporate environment. So you can say, we want to reject that version because it's a known bad version, right? And then 512 final is the one that is selected. Yeah, if we run in info mode, you can again see there are now 3 candidates that were rejected for different reasons. The selection criteria are powerful. It's not just the name and the version. It's the branch from which you build it if you want. It's the metadata status. Is it a milestone or a dev or QA release, right? So it's a very powerful language you can have. And what is important to understand is depending on where you're building, you can inject different selection rules. So for developers, you can inject the rules. Whatever is the latest, you get the latest, right? And then for QA, you can say, hey, for the QA build, we will never take anything with alpha or beta. So you now can get in dynamic dependencies depending on the environment you're building in, right? And that is something that was always missing when you were using Maven snapshots, right? It was just give me the latest, right? But you could not specify additional criteria, and Gradle provides you with that. Another big scalability capability for people, for organizations that use dynamic versions. Okay, so another thing, I will skip the example for that because I want to show something else. What you can also elegantly do with Gradle is when you have a large multi-module build, let's say 300, 400, 500 modules, right? And your developers don't want to check the whole source tree out, right? You can easily have a setup that developers can check out only 10 modules of that build, and then Gradle automatically replaces the other potential dependencies those modules have on the other modules that are not checked out with external dependencies and gets that from a repository. So that's what we call Fluent Dependencies. What I want to show you, this is a live demo, the other demos are pre-recorded, is the latest feature we have in Gradle we call Composite Builds, right? So I want to show you a little example. So this is a sample project, and it has 3 independent, so this is not one multi-module build, those are 3 independent Gradle builds. You can see project B has a settings.gradle, right, and has submodules B1 and B2. Project C has own settings.gradle, and project A. In these samples, they live close together. They could live wherever on the machine. Those are 3 independent Gradle builds, right? You can execute them independently, and when you look at the dependencies, I make this a little bit bigger. When you look at the dependencies, you see project A, right, has a dependency, an external dependency on B1 1.0 and B2 1.0. And those are the dependencies that are built in a project B, in a submodule B2 and B1 and B2. Okay. So what you can do now is you can now have an additional build. It's called a composite build, where you say I want to build project A, B, and C together. I want to aggregate independent Gradle builds, right? So and then so let's do this. You can say Gradle show dependencies. This is now when a composite build is not in action, and you can see project A has an external dependency on B1 and B2 has an external dependency on project C. Okay? So it's a brand new feature, so we have a feature toggle to switch that on. It's -p integrated. And what you can see now Composite Builds is activated, and Gradle sees, oh, this dependency is actually replaced by project B2. Does this make sense, right? Because we see this is now another Gradle build that you have checked out locally, and Gradle just checks, okay, project A, B, and C are now aggregated, and every dependency those projects have between each other that are declared as external dependencies are now replaced with project dependencies. So you can now aggregate any Gradle build you want, right, and together and execute them together. And then the output of the build is taken versus the external dependency. So imagine a scenario that usually you work on project A and you always take the released version from project B. But now you have to do some complex refactoring within A and B at the same time. Now you just say, hey, I check out project B, tell Gradle, treat them as a composite build, and then Gradle will automatically always take the latest from B instead of using the external dependency. And there are many other reasons why this is a cool feature, right? So this is also supported with our IDE integration. So from next week onwards, when you import projects into Eclipse, right, Gradle will realize, even if project A has an external dependency on project B, if project B is imported into Eclipse, they will be treated as an Eclipse project dependency, and you can refactor them together. And IntelliJ will follow soon. So I'm super excited about that. And I think you as well. So we worked together on some of that stuff. And then the next step for composite builds, I mean, we still have to do work to make it fully polished, but the next step is that you then can have composites that live on different machines. So that's when we're getting into remote builds with Gradle. So I'm super thrilled about that. Anyhow. Let's continue. Regarding dependency management, there are amazing additional community plugins out there. So Netflix contributed really cool ones. So for example, the dependency locking plugin, that when you use dynamic dependencies, that you can always lock the last state of the resolution and put that in version control, that you can always reproduce build. There are blacklist and whitelist plugins out there. There are a lot of cool plugins out there that add additional high-level feature around Gradle dependency management that matter for the enterprise, right? So for example, I think the black and whitelist plugin, you can specify on a server, right, in a JSON file, all your black and whitelist rules, right, and then they are shared across the whole enterprise, right? And you can say, hey, warn these people if they use that version, or let the build fail if they use that version. That is all what matters when you do dependency management at scale. One feature many people are not aware of, it's one of my favorite features in Gradle, is the continuous mode. I will show you a little example. Who is aware of the Gradle continuous mode? So check out this example. So here we have the Gradle. We're not building any Java. We have a little ASCII Dockter project, right? Who knows ASCII Dockter? It's a markup language that is more powerful than Markdown. But not so heavyweight as DocBook. So I think O'Reilly has fully switched to ASCII Dockter. It's a very cool format whenever you write something a little bit more complex, right? And we have here an ASCII Dockter project, right? And adoc is the ASCII Dockter markup file, and it's a manual for some Java project. And now we tell Gradle, hey, transform the ASCII Dockter markup file into, first we look at the ASCII Dockter markup file, that you get an idea how this looks like. Right? And you see this is an ASCII Dockter markup file, right? And we now tell Gradle to transform that into HTML. So we open now the transformed HTML page, and that is how it looks like. OK. So now we change the ASCII Dockter markup file. Let's do something exciting. We go back to the command line, rebuild the ASCII Dockter HTML, generated HTML page. We go back to the HTML page, and you see the page has now changed. That was not the exciting bit. No worries. So what we do now is we now tell Gradle, hey, run the ASCII Dockter task in continuous mode. And that is when Gradle turns into a local build server. So you see Gradle is now waiting for changes to input files of the ASCII Dockter task. And the cool thing is, because Gradle has a rich input and output model, not like with other watch plugins, you don't need to specify any file patterns or whatnot. You just say, run this task in continuous mode, and Gradle then automatically knows which inputs to watch. You don't need to tell this to Gradle. You can even do this in a multi-module build when you have 500 submodules. You can go in the root project and say, Gradle compile -- continues, right? And it will watch all the 500 submodules and will rebuild them with any of those changes, right? So let's see how this works. So we change this now, right? And we click save. And now we don't need to do anything. We just need to refresh the browser. And Gradle automatically, right, has rebuilt that. Continuous mode introduced with Gradle 2.5. So let's do it one more time. We click save. And without calling Gradle, we just refresh the browser. And you see this has been rebuilt. And if you go to the command line, you see change detected, executing build one time, and change detected, executing build another time. And we added one more cool feature to that capability. So I think in 2.10. So what happens if you do a change in this ASCII Dockter file, right? And then it takes, let's say, 20 seconds to build. And within those 20 seconds, you do another change to the source file. In version 2.5, this change was then ignored, right? In the latest Gradle version, we now continue to watch to file changes. So even while Gradle is rebuilding the next HTML generated version of your file and you do further changes, we keep them in the queue. And once Gradle is done with building the new HTML page, Gradle knows, oh, there are further changes, and it automatically rebuilds again. Right? So it's now really like a local build server. And you can use this for many, when you do web development, it's a really cool feature. It works with every task. Okay, so yeah, who of you is using Eclipse? Just get an idea. Okay, so really good Eclipse support for Gradle, but IntelliJ support is also getting better and better. So you're served well on both IDEs. Performance is obviously a very important aspect of scalability. Not the only one. We have seen other ones, but it's a very important one. So if you want to have the fastest Gradle build, use the latest Gradle version. So we did some significant improvements in 2.13, and there are more performance improvements to come. So you can expect pretty dramatic improvement when it comes to configuration time over the next 1 or 2 Gradle releases, right? So that's one area we're working on heavily. And there are also many other areas. Performance is for us a constant stream where a few people work on. So there's a lot to come to make Gradle builds faster and faster and faster. So one other thing we're working on is daemon stability, right? So using Gradle without the daemon is a much slower experience. At the same time, we see problems that people use custom extensions with the daemon, or they use some external plugins that are leaking somehow, right? And making the daemon unstable. And yeah?
When's 2.13 getting released?
I think next Monday. Yeah. When is 2.13 going to be released? Next Monday. The release candidate 1 is out. So what we are working on for the daemon is some auto health checking, right? That we realize, hey, we're getting memory is getting scarce, and we need to automatically restart the daemon and things like that. So we want to make the daemon rock stable, right? Even if it's used with extensions that are kind of polluting it, right? That at least you pay a performance penalty when a daemon gets restarted, but at least your build is not stuck. The other thing we have started to work on is the distributed cache. So basically that any build output can be shared with any developer, right? Yeah, that is a key feature, most importantly for C++ and native builds, but for Scala obviously as well, and also for Java, it will give a really nice performance boost to at least to larger projects. So we're super excited about that. Distributed builds in the context of composite builds is something we're going to start to work on in the second half of this year. The other thing we're super excited about is Gradle.com. So if you want to learn more about a SaaS offering, we are going to provide to all Gradle users. Go to Gradle.com and check that out. It's a capability that you can connect any Gradle build, right, with the SaaS service, and it collects metadata from the build, and it can give you insight of how, what happened during that build execution. We're building in analytics functionality that you can see how is your build and certain problems evolving over time. So there's a lot to come there. So if you're using Gradle in a serious way, check this offering out. If you know people that are interested in getting started with Gradle, or if you're just getting started with Gradle, there is a really good Udacity class out there. It's free. It's amazingly produced, super high quality, Gradle for Android and Java. Excellent course, right? We did that in collaboration with Google. When I did a screenshot, it was 2,700 students. It's now 16,000 students. It's one of the very popular Udacity classes. So if you want to get deeper into Gradle, Gradle Inc. offers a really, really good instructor-led training, online classes delivered by Gradle core engineers. So it's knowledge on the highest level. Very much to recommend, right? And yeah, that's it. Thank you.